We are witnessing a rapid revolution in 3D printing. However, due to measurement error and hardware imperfection, it's still challenging to make daily objects fit with a new 3D print. We introduce FusePrint, a DIY 2.5D printing technique that embraces everyday objects. It's based on SLA 3D printing with a DLP projector. FusePrint can fabricate new parts that tightly fit objects from our daily life. For example, printing a well-fitting ring and details of an internal screw thread. There are three main components in the FusePrint setup: design, print, and post-processing. Here we use the example of printing a pen holder to introduce the process of using FusePrint. The sketch interface allows users to design printed shapes and use physical objects as references to specify the height and the position of the physical object. They can then export the design data. Then they use the PowerPoint plugin to load that exported data. This generates the slides for projection with specific shape colours and advanced timings. Users can now play the slides and place the resin above the slide projection. User places the physical object in the resin once they're notified by the red slide. Once they've finished all the slides, the user gently peels the printed object off, washes its surface with alcohol, and treats it with water and UV light exposure for 3 minutes. Then they polish the part with sandpaper, as necessary. Finally, users made a pen holder that tightly fitted the two different marker pens. To print a ring that fits the finger perfectly, a user just needs to create a wrapping with a piece of plastic or paper around the finger. They place the wrapping in the resin inside the projected circle. The inner printed part can be separated easily and leaves the ring. To print a detailed internal screw thread on the object, users can place the screw in the resin. Thus, the resin will be cured around the screw and follow exactly the shape of the screw thread. By mixing photo-reactive resin and conductive gel, we can print conductive and touch-sensitive objects. Different printed shapes can have different conductivities and touch sensibilities. Here we show the products created by the workshop participants. By sketching along the edge of the mobile phone, a pair of phone stands were created. Users also quickly created new parts for toys. Two printed parts can be swapped between toys to create new combinations. One engineer participant printed a screw assembled structure. It can be put into the wall and become a hanger. FusePrint can also create mechanical parts, such as propellers that fit the motor pivot. Lastly, a designer printed a conductive accessory to fit his glasses, helping to rapid prototype interaction techniques for wearables.